Sir, would you please share these files with me, sir?
Sure, sure, definitely, definitely. I will upload to server and then I will share. Right. Right. So till now what we have discussed is the quantum Fourier transform of X. So one more time, let me write this because now we are going to construct the circuit. That means the circuit corresponding to quantum Fourier transformation. So once again, please go through the transformation. This is the QFT of X, that is X tilde, which is 1 over root n. Now carefully see, the first expression 0 plus e raised to 2 pi I, we are taking x by 2, 1. This is the first one, first term. And the second term, if you understand this, then only we can construct the circuit, sir. 0 plus e raised to 2 pi I x by 2 square get 1. Okay, plus so on like this. Okay, let me write the third one also because we are going to write finally 3 qubits. E raised to 2 pi I x by 2 cube 1. So on, so on. So 2 power n, okay, fine. Now sir, carefully see. What are these tensor products? Please tell me. How many products are there? N products are there. Okay. So n, yeah, 1, 2, 3 like that n. You please tell me what are these tensor products? Why we will make the tensor product output? This is the output. Means you have given the input as x and you are getting this is the output. Now we are going to construct the quantum Fourier transformation circuit corresponding to this output. Now please carefully understand this output. Why we will make the tensor product in the circuit, in the quantum circuit? First we will take the vertical, okay. While doing this vertical, we will take the tensor product. Tensor product between what? Qubits, right? Now tell me. So this first term corresponding to the first qubit. Say yes or no.
Yes.
This one corresponding to the second qubit.
Yes, from the rightmost we will take.
Yes, yes. Yes, finally this will be the for the nth bit. This is what we understand. Okay. Sir. Now see. So you have taken one qubit, first qubit, sir, first qubit, whatever it is, okay. So you have taken first qubit, it should become 0 plus e raised to 2 pi I x by 2 1. That means you have taken x for example, or x1 you have taken, it should become like this. It may be x1, x2, x3, anything, just I have written. Who will do this?
Sir, one quick question. So, why are we jumping back x by 2 instead of point x? Sir?
Oh, that point is not required actually. If we want, right? You can write. This is enough actually.
No, that's fine, sir. This is good. This is good.
Anything you can use. Anything you can use.
Okay.
Next example, we will use that decimal. No issue. Sir, who will do? I mean, which gate will do this transformation? That's it. So that's why on every first qubit, on every section, the first qubit head mod will be operated. That's it. Nice. So the first requirement is the head mod. If you take this, I think I need not to explain. You understand already. Plus e raised to 2 pi I x by 2 1. That's good.
Yes, sir.
Next, come to the second. This is related to our second qubit. In our second qubit, what is happening? The phase of 0 remains the same, but the phase of 1 is changed to e raised to 2 pi I by 2 square. Third qubit 0 phase is as it is, but if it is 1, its phase is changed to e raised to 2 pi I by 2 power 3. Third qubit e raised to 2 pi I by 2 power 3. Now tell me, if I am doing on the mth bit, what could be the phase of this one?
E to the power of 2 pi I x by 2 to the power of n.
No, only phase.
Yes.
E power 2 pi I by 2 power 3. X is not come. This is of only phase. I am talking about the phase.
Okay. E to the power of 2 pi I by 2 to the power of n, sir.
That's it. So we need a rotational operator. We need a rotational matrix which can change only the phase of 1. Is it clear? Who will do this? I think I am taking a rotational operator. Some textbooks will take R, some book will take U.
U. We use U, sir. U.
Okay, fine. So I am taking U rotation. Okay, right. Now careful. So what is this matrix? This has to, see, if it is a 0, no change. If it is 1, the phase must be changed by e raised to 2 pi I by 2 power m. Okay, that's it. Okay, that's why the people will write it as 1 minute. I will write your notation only. They will write like this, un. Sir, what is this un?
Un is unitary matrix.
What is n?
It will be tensor.
No, operating on nth qubit.
Oh, okay.
This is operating on nth qubit because I told you on second qubit it should be 2 square, third qubit it should be 2 cube, nth qubit it should be 2 power n. That's why we are using this notation. U rotational n means if it is operating on nth qubit, the phase of 1 is changed by e raised to 2 pi I by 2 power n. So I will tell you a small example, sir, please. So this is x1, first qubit. On this, what you are applying? It's very clear, Hadamard. Because no need.
Can I ask you a simple question?
Yeah.
I know you have proven it up there. So essentially, if it was at 0, it became 1 because it was 2e to the power of 2 pi I. X value was 0, so it became e to the power of 0, which became 1.
Yes.
So 1 into cut 0 is cut 0 only.
Yes.
That's the reason why we only attach it to 1, because the value keeps changing. Correct, sir?
Yes. If you want more general, this is the general one actually. For ket 0, nothing will happen. For ket 1, e raised to 2 pi I x by 2 power n. This is the more general. That x can be 0 or 1.
It doesn't have effect on 0 is what you're saying, but on 1 it have a terrific effect.
Yes.
Okay. Yeah.
So this Hadamard is over. Now on the second, sir, this one. Actually, we are using this rotation as a control, that to reverse. That means U rotation. This is, sir, on which qubit it is operating?
2.
That's why you will write 2 here. Now, it's very clear. This matrix will change the phase of this only when if it is 1. If this is a 0, no change. Am I right?
Yeah. But will it change the phase of x1 or x2, sir?
X2, sir.
Okay. Control is landing on x2.
Yes.
So target bit is x2 and control bit is x1.
Target bit is x1, sir. No, reverse na. This is reverse na.
Okay, got it.
Or what is your doubt? Please tell me. I'm getting confusion. Okay.
So,
This is a reverse one.
so x2, when x2 is 1, you are trying to say you're trying to influence x1 qubit, correct?
Yes, yes, exactly. Yes, yes.
So x2 is the control qubit and x1 is the target.
Yes, yes.
Okay.
Hmm.
Oh,
Right. So finally we got this U rotational. So n times operating, then its matrix should be 1 0 0 e raised to 2 pi I by 2 power n.
2 to the power n.
Okay. So whenever they have written like this un minus 2, this is connected with n minus 2 qubit. Just remember that. Okay. Right. Okay, fine. So we got the two gates, and now I am going to construct with the first. Shall we go with the 2 qubits itself?
Yes, sir, that will make it easy, sir.
Right. Now I am taking 2 qubits. Right. So only I have this x1 and x2. Right. Okay. Now once again I am writing this 2 qubits QFT. QFT for 2 qubits x1 x2. I hope you remember. It's 2 qubits, that's why under root 4 0 plus
Plus
e
e to
raised
the
to
power of 2 pi I x by 2, get 1, tensor, get 0, plus e to the power of 2 pi I by x, to, x by 2 to the power of 2.
good. And now this first one can be done by head mod. Rotation is not required. Okay, is it clear?
Yes, sir.
Yeah. So now on the first one I am taking head mod. So I am taking a vertical line. So here let us suppose this is the psi 1. That means after this operation what is my psi 1? Okay, right. So what is the psi 1? The psi 1 is nothing but head mod is operating on that, that is a 0 plus e raised to 2 pi I x1 x1 x1. Is it okay? Shall I write like that or x by?
No, x1, sir, that will be very clear. That is a beautiful representation. X1 I ran.
1 minute. Here is the problem. If you want to write x1, you should write in the point form only.
Oh.
Why?
Okay.
I hope you understand what I am saying.
Let's go by x by 2 to the power of
X by 2, okay?
2 to the power of 1.
1. 1 minute. So I will write here 0 e raised to 2 pi I. Now this is the x1. X by 2 means what? X by 2 means what? I think you remember this is a point x2. x2. No.
Correct, sir.
Point x2.
Because x1 became x1 died because we moved to the
Yes,
left of
yes,
and
yes,
it
yes,
became 1.
yes. Point x2. Is it okay?
Yes, yes.
Right.
Beautiful.
Right. So now what we are doing is we are taking the rotation operator. This is u rotation, and this is that's it. And it's taking the control. That means I think this is the control bit, na sir. This is the target bit. Am I right?
Correct.
Right. So it is controlling this x2. Fine. That's why this notation is a 2 2. Okay, fine. Now after this I am taking psi 2. Okay. So now what is that psi 2? The psi 2 is nothing but
Sir, if you don't mind, for this fellow, can you write what is the target bit and control bit, sir? Because that is what's confusing me to be able to think further. means two barriers you created, no? Side 1 and side 2. Can we just write C and control and PRE and let
I will do one thing. Okay. Wait. Understand. Now you please tell me what is this operation actually, this one. H tensor I x1 x2. Is it okay? This first one. So H is operating on x1, tensor x2 as it is. That's why we got, that's 1 by root 2, of course. I am not taking that constant, 0, and e raised to 2 pi I x by 2. If you want to write the x by 2, am I right, sir?
Yes, you're right.
I think x by 2 or x1 by 2. I am getting that confusion, sir. Please wait 1 minute.
No. If you want to put a point, then it will be 0 point.
No. We are doing mistake, sir. We are doing mistake. 1 second. Wait. Sir, forget about this. QFT, forget, please. Because what is the problem? If you take that, whatever the answer we are getting, after that finally we have to apply swap. Just that's why please I request you please forget this and let us apply like this. Now I got the clarity. H tensor I x1 x2. Okay, sir. H is operating on x1. Could you please tell me what is this operation? 0 plus e raised to 2 pi I. Earlier what we think that is correct, sir. x1 by 2 ket 1. The reason is, what is this head mode operation? See, if it is x, x by 2. If it is x1, x1 by 2. That's it. So, okay. And tensor x2 is as usual. Is it okay?
Yes.
Now see. Now come to this. So what is this? This is the CU rotational operator. Okay. Now this is operating on this. Now tell me which is control, which is a target. Now what I am saying is, this is
the control, sir.
That's it. This is as it is, and on this you are operating this U2. This is what I want to say.
Yeah, okay.
So operating on, 1 minute. This one no change, sir, as it is. This is operating on x2. Okay. This is as it is. 1 minute. Now please go back to the U rotation. What is this U rotational matrix? It will operate on x, for example. Okay, what it will do? So if it is a 0 as it is, if it is 1, the rotation is how much? This is e raised to 2 pi I. It is x by 2 power m. M kada n anukundam. 2 power n. This is un.
Yes.
Now you are having u2 on which bit? x2. I think it's very clear. x2. Okay. Now this is, could you please tell me, 0 e raised to 2 pi I.
X by 2 to the power of 2.
No, not x.
X2.
That's it. x2.
X2 by 2 to the power of 2.
That's it. Into 1. Is it okay, sir?
Yes, sir.
Now see. Finally, of course, here I forgot to write the tensor product. Sorry. Now this is your second state. Means after operation of a controlled rotation, this is your psi 2. Am I right? Could you please tell me what is my psi 2? Psi 2 is this one.
The whole thing.
Yeah, that's why 0, one more time, e raised to 2 pi I, x1 by 2, 1. Now tensor, already I operated here.
Get 0 plus e to the power of 2 pi I x2 by 2 square. To the power of 2, sorry.
That's good. Now listen. Now we are making the tensor product. Okay. So don't compare this. Just leave it. Now we are making the tensor product. This is 0, 0. I think there will be no change in the 0. Next what you will get, sir?
We can take plus 1 and then we can take
E raised
maximum
to
plus 1
2 pi I x1 by 2
2 plus 2 by 2
x2 by 2 square.
e power of 2
Is it
at
okay,
1.
sir? Is you understand
Yes,
this?
yes.
Now please go back to our notation again. Decimal notation. This is what I said. Here it is very useful. What I told you, x1 by 2. How much?
Point x
Point x1.
point
No, correct
x
only. Point x1. x2 by 2 square.
point x
Point
point
0 x2.
x1 x2.
Mm, this not x now. It's one a single one x2.
Single cube itself. Okay,
Ah,
so it is point 0 x2.
that's good. That's good. Point x1. This is a point 0 x2. Now this total value is what? A point
x1 x2.
That's it.
Okay.
Got it?
Of cat 1.
So finally this is nothing but 0 e raised to 2 pi I. You can write like this also. x1 by 2, x2 by 2 square. So x1 here and x2 here. This is your final psi 2 state. Okay? Okay, sir.
Yes, sir. Now
Right.
the beautiful question arises of what you mentioned earlier. Why the stack gates need to be used?
Yes. Now I am taking the final output. How we will get the final output? We have to multiply the verticals. First here we have written only verticals. First vertical we have written here. Where? Here. Okay. And second vertical this one.
Correct.
Now we have to multiply from this side to this side. That's good.
Correct.
That's why my final output is this into this. Am I right?
Yes.
So that's why now this is a 0 plus e raised to 2 pi I point x1 x2 1. Of course normalization factor is there, sir, into.
Yeah.
Here I forgot to write that notation. I am writing this here. Okay. So or otherwise here.
Point x or something.
Yes. Point x1 ket 1. So that side 0 plus e raised to 2 pi I point x1 ket 1. Okay.
Sir, did you miss the tensor x2?
Which one?
The tensor x2, the yellow line.
Oh, shall I clear that? That's what you are asking.
No, don't we need to multiply it here when we multiply the thing from the right side?
No. Actually, this step I have written.
Oh, I got it. Okay. Yeah, okay, got it. It's not a problem.
x2 will be as it is. On that x2, this unitary operator is operated. That's why we got like this.
Got it. Yep.
Fine. So this one you got. Now I want to ask one thing. Now come back to this. Sir, now we have already explained this binary fraction. After that decimal you have represented. Am I right? Now forget this. I request you please say quantum Fourier transform of x1 x2.
Cut 0 plus e to the power of 2 pi I.
Okay. 2 pi I, correct only.
2 pi I and point x1.
Are you sure?
It is right twist. Okay, so point x2, I think, sir.
See this one, x1, x2, s3. First one, what you get?
x3.
I told you, x by 2. That means from that side, point x3. X by 2 square, point x2, x3.
Got it.
Okay. So now, by using that, I request you please tell me the Fourier transform of this.
It is point x1, sir. First bit. Sir, if you look at the left.
No, don't see this one, sir. Don't see this one. One more time, please, please. Already earlier you said this. x1, x2, x3. Then, what is the Fourier transform we have written? X by 2 first, x by 2 square, x by 2 cube.
Got it.
X by 2 means from the last you have to take the dot.
Okay, so it is point x2, sir.
That's it, that's it. Now you will understand why they are swapping dot. Now tell me the next term in the Fourier transform.
Yeah, into tensor into e to the power of 2 by I point x1, x2.
Now please check. This is from the circuit you got. This is actual Fourier transform. Something is not matching.
Okay, so sir, are you trying to say that the first term, which down if you see the psi f, the final output, you are trying to say that it has become point x1, x2, cut 0? Is that what you are trying to say, sir?
One minute.
x2 is the last 2 to the power of 0 term. So we took x2, point x2, correct?
No, sir. Oh, you have done a small mistake. I'm sorry. No, not a big mistake. Okay, 1 minute. I want to correct it. Wait a second. So this is no doubt. This is our Fourier transform. Okay. 1 minute. If you don't mind.
Go ahead.
I'm sorry. Wait.
No, absolutely. So this is a good learning actually.
Actually, writing on the papers, okay. But whenever we are saying, okay, it takes some experience. It needs some experience. Okay, fine. So this is the Fourier transform, and we are constructing the circuit. Okay, fine. So earlier you raised me one question actually. That is correct. So why I forgot? Okay. Anyhow, so this is my H tensor I. Sir, first step I am writing. Okay. This is the psi 1, sir. So psi 1, how to get psi 1? This is the H tensor I. This is nothing but x1, x2. So H will operate on x1, I will operate on x2. That's why this is, I am not considering that 1 by root 2. So e raised to 2 pi I x1 by 2 ket 1. Next x2 as it is, sir. That means the tensor x2 is as it is. Now the next step. Moving to the next step. Moving to the next step. So moving to the next step means this operation. This one. This is what? Psi 2. I will take another color. Psi 2. Now what is this psi 2? Now psi 2 means here you got already psi 1. This one is going to operate on psi 1. Say yes or no? So that means your control rotational operator, that means C, U rotational, and here control bit is x2, that's why it is 2. Now this is operating on psi 1. Okay. Now this is nothing but 0 plus e raised to 2 pi I x1 by 2, slowly, 1, the tens are x2. So, now your operator is coming here. U
Yes.
rotation, sorry, U rotation, this is 2 operating on x2.
X2.
Sir, this is a psi 2, it's not the final state, it's psi 2. Okay, now
Yes.
psi 2 equal to 0 plus e raised to 2 pi I x1 by 2 1. Now already earlier we understand 0 plus e raised to 2 pi I operating on x2 2 times, that's
Yes.
why 2
To
square,
the power of 2.
that's it. Now please multiply 0 plus e raised to 2 pi I x1 by 2 plus x2 by 2 square into ket 1. Now this is 0 e raised to 2 pi I. If you want you can write it as x by 2 power 2, correct only, x by 2 power 2 or decimal notation point x1 x2. This is psi 2. That means finally I got psi 2, but it is not matching with my answer. What is missing, sir? Please observe. This term I got already. One more term need, this one. Could you please tell me how you will get this? Observe. We want only point x2.
I have to operate on that x2.
Which gate? Point x2 is nothing but x2 by 2. x2 by 2, which gate?
X2 by 2, which gate? That will be your rotation.
No. Only 2.
Okay, Hadamard.
That's it. This is what we forgot. Again, we need to apply Hadamard on this last one. Every circuit, please remember, last qubit again you have to operate Hadamard.
Okay.
Then only one cycle is completed. Then only that final output will come.
Let us see how we will operate on this point x1, x2.
Yeah. Ready, sir?
Ready.
Now H is operating on what? x2. So you already got psi 2. That's why my psi final equal to psi 2 as it is, no change. Now this Hadamard is operating on x2. Okay, you didn't understand. One minute. What is this, sir? I, tensor H, operating on psi 2. This is psi 2, na?
Correct.
Psi 2 tensor this last bit.
Yeah.
x2. Is it okay? Okay?
No, sir. No. See, what you said is the identity you have taken on the top, and you are going to operate the Hadamard on the output of the psi, no, sir? Okay, so you said identity tensor H.
Sir, this psi 2 is here.
Oh. It's not there on there, sir? You wrote
Okay. This one I have written. Okay.
operate Hadamard on psi 2. Hadamard on psi 2. So then you make again psi 2 is equal to that 0 plus 1 by root 2, and then again apply here on 1. It will become ket 0 minus e to the power of 2 pi.
Actually, psi 2 is as it is, sir. Now I am operating Hadamard on x2. Okay. So what is this? Psi 2 tensor, sorry, not tensor. Psi 2 into, Hadamard is operating on what? This is x2. Because one more gate we are introducing now.
Yes, yes, yes. Hmm.
Okay, so 1 minute. Okay, while we are explaining 3 qubits, you may get the clarity. Okay, let us proceed now. So now I am operating head mod on x2 again. So after head mod, this is my psi final, sir. So psi final equal to psi 2 is as it is into your head mod operating on x2. That's why psi 2 as it is.
Mhm.
Please tell me h operates on x2, what it will be? 0 e raised to
Yes, sir.
point, sorry, e raised to 2 pi
2 pi
I.
I point x2 and yeah, point x2, sir.
Because x2 by 2 is nothing but point x2 1.
Yeah,
Is it okay, sir?
yeah.
Now check.
Hmm. Now it is in reverse order.
Reverse order. That's why we will apply after psi final a swap gate. Then it will be reverse.
If you don't put hard or not, then you are having only x, so it's pointless. You're not getting an output.
No, we won't get. It's not complete circuit. Actually, that is the confusion I got. Actually, I thought that head mod is not there. Head mod must be there. Finally, head mod must be there.
Mm, mm, mm. So, oh, these bits swapped.
Hmm. Oh, this one. This entire thing and this entire thing swapped.
Mm.
Because whatever the output you got here, it's a swapped. Swap gate will do that only.
Mm, mm, mm.
Okay.
Yes, sir.
Right. Now, wait a minute. Let us construct for 3 bit 3 qubits.
Mm.
Is it okay? Are you? Is
Yes,
okay?
yes, yes, yes.
3 qubits. So if you observe carefully, one pattern is there. See, first qubit is very crucial, sir. Always we have to operate head mod.
Mm.
After that, next qubit you are operating this U2. U2 stands for operating on second qubit. Okay, sir?
Mm. Mm.
Right. Like that, you have to operate U on every qubit except first one.
Mm. Mm.
Except first one, you have to take this control. You have to take this control for every qubit.
Mm. Mm.
Right. Now come to this. I don't know whether I convey correctly or not, but what is the meaning of that? See. Now this is x1,
Mm.
x2, x3.
So you know how you can make it easy? So in the yellow you wrote 3 qubits, right? So you just write in regular or binary format x1, x2, x3, so then it will be very easy to connect the dots. Ah, beautiful. That will help.
This is what you are saying? No.
Mm. No, that's it, sir. Leave it
Okay.
x1, x2, x3.
Right.
That's it.
Got it. Now, okay. So the first always will go with the head mod. After
Before I
that,
tell you the output,
whatever. No.
can I tell the output, sir?
Yeah. Why not?
Yeah. So the first output will be x0 plus e to the power of 2 pi I x by 2 to the power of 0 x1 sorry x1 by 2 to the power of 0
Hmm.
uh,
Get one.
that's get 1.
And then.
Okay, that will be your sub 1 state.
Yeah, first one.
Okay. Now what we'll do is, taking x2 as a control, we'll put an u operator there on x1.
Yes. This is you
You
operating on 2.
2 to dot.
Two rotational. Okay.
So your so essentially you put a chukka here on x2 and push the values. Yes, sir.
Right.
So essentially what you are trying to do here in the second part is you're trying, sir, but shouldn't we be putting in a header mart for the second fellow x2?
No. After complete rotationals, then only finally we have to take the head mod. One more rotation is there. I told you what I told earlier. This rotation we have to do as a control bit except the first one. For all the remaining qubits we have to take the control except the first one. That means one more rotation will come. This is U rotation. This time
We on the third. But let me finish this. Sir,
Yeah.
you wrote square. That's
Yes.
okay, you don't need to delete. So this into actually it will be a tensor of x2, is it not? It will be a tensor of x2.
No, here what you are saying, here what you will get.
Here we'll get psi 3, no?
Sir, here x2, x3 as it is. We are not changing anything after the first one. Okay? This is psi 2. Now this psi 2 is taking control of what?
Control x2.
X2. That's why your psi 2 will be, this is psi 1. Psi 2 will be, first one as it is. I hope you are observing. No change. Okay, tensor. Now this one is taking the control of x2. Now tell me.
That 0 plus e to the power of pi I x2 by 2 to the power of 2.
That's it. And x3 as it is.
And x3 as it is.
Now one more rotation we are taking. I didn't remember. I think they will write here 2 power.
No, there will be 3, sir. They will write 3.
3, sure?
Sure.
Okay.
Because they don't say, they'll blindly say you believe it to be 2 to the power of 3. They say you write it
So
as
how I understand, 2 for operating on second one, 3 for is this one, like that. x3, 3.
Yeah, that is the third qubit.
Yes.
You need to read it as 2 to the power of 3.
Yes. Now I am taking psi 3, sir.
Now let me tell this. So
Yeah,
psi
sure.
3 is equal to the whole thing here.
As it is.
Yes. Tensor 0 plus e to the power of 2 pi I x2 by 2 square 2 to the power of 2 into tensor of ket 0 plus e to the power of 2 pi I what is it, x3 for me, x3 by 2 to the power of 3.
That's it.
At 1.
That's it. Now if you multiply
E to the power of 2 pi I x1 by 2.
Shall I write directly?
Yeah. Go ahead, sir. x1, x2, x3.
That's why they are using this notation actually.
I got it.
Writing all those things, that's why they are using this. This is your psi 3, sir. It's not over.
Now we need to apply head nod.
Now, if you observe carefully, can you please tell me, in the Fourier transform, after doing these gate operations, how many terms we got? Not understand the question. No. 3 qubits Fourier transform contains 3 terms. Out of the 3 terms, you got only 1 term now. Please check. Okay? Let me tell you one more. Somewhere we have written. Yeah, here. This last term you got. Now we have to get this. So this is not the final output actually. This is only 1 term of the quantum Fourier transform. Because already we have written 3 qubits. This is the 3 qubits Fourier transform. If you see carefully, this last one and whatever we got now is the same.
Yes, sir.
Now still 2 more terms are there.
Mm.
Okay, so right, now let us proceed. It's not over story, this one. Okay. Now start, sir.
So why can't we actually do a tensor multiplication of point x2, x3, okay, and then you shift it again to the left on to point x1 with what you got in the last line, y3. Why can't we tensor it with, we know beforehand that point x1, x2 is for the second qubit.
No, what I am saying is, now how you will construct the second term? This is what I am asking actually. First term over.
Oh, okay.
Now second term you are going to construct. If you observe carefully in this expression, sir, this is the first term. I mean, for our circuit, this is the first term. Contains all x1, x2, x3, all terms are there. Next one, what is missing, sir?
Second qubit, sir, from the right side. So it is
No. What is missing? What is missing?
x1 is missing.
X1 is missing. So we have to start the process from x1. Sorry, we have to start the process from leaving x1. I don't know how many, you understand or not. One second. What I am saying is, if you apply head mod on x1 and then u rotation on x2 and u rotation again on x3, we got this. Now,
so you only got answer for x1. If you look at the top where you wrote 3 qubits in yellow, you got answer only for x1, the leftmost.
Yes. Now we don't want this x1. We have to get another 2, right? So that's why what I am saying is, leave this x1. Start the same process by taking as x2. That's why starts with the first one, head mod. After that, rotation.
From x3.
Yes. I hope you got this.
Yeah.
Now, if you find this separately, you will get the second term.
Correct.
Shall we write directly?
Yes, sir.
Because this is on x2, that's why what you will get? Point x2.
Point x2.
Here after rotation, what you will get? Point x2, x3. If you add, this is a 0 plus e raised to 2 pi I point x2, x3. Sorry. I'm sorry. Point 0 x3. Okay. Okay, na sir? Fine?
Okay, sir.
Right. So that's why this is, if you add both point x2, x3, 1.
Correct.
Now, one more term is there. So this term we got, and the last and final we need to get this. Now you please tell me, if you want to get point x3,
We have to take the x3 guys now.
x3, what gate you will apply? We want only one term, only one point. That's why head mod. So what head mod will give you after this? What head mod will give you after this means?
x0.
Yes.
Plus e to the power of 2 pi I.
Yes.
Point x3.
That's it. Now you have to multiply this and this and this.
Not tensor, no sir.
Not tensor. Over now. This is one part, this is another part, and this is another part.
Yeah.
Sir, simple sir. First head mod will give you point x1, sir. Next rotation will give you on x2 point 0 x2, sir.
Right.
This rotation will give you 3 times 0.00x3, sir.
x3.
If you add all, you will get this.
Yeah, yeah.
Next, come to this. Similarly, Hadamard will make x2 as a point x2, sir. If you rotate this third one, it will give you 0.0x3. Then if you combine this, you will get x2, x3. Now only Hadamard on x3, that is x3.
Yes.
That's it.
Okay.
Now, shall we, can you try for 4 qubits?
Oh yeah.
Is it okay? Or otherwise you can try later, your wish.
No, I can try later, sir. I can do it as homework and then.
Yes. Is it clear, sir?
Oh yes. So later we can do, probably tomorrow we can do the inverse quantum.
Yeah, sure. Just practice this, sir, once, okay? Then we will do that.
Sir, is it possible for you to upload the video?
Yeah, I will upload now. Now I will upload.
ఎందుకంటే ఈ ఫోర్త్ చేసినప్పుడు ఇఫ్ యూ స్విచ్ రికార్డింగ్ ఐ కెన్ టాక్ విత్ యూ.
Yeah.
అది అప్లోడ్ చేస్తే నేను 4 నేను చేసుకుని మీకు చూపిస్తాను సార్.
తప్పకుండా సార్.
ఫోటోస్.
షూర్. ఏమన్నా మీకు
కాన్సెప్ట్ బాగా నచ్చింది సార్ మీరు ఎక్స్ప్లెయిన్ చేసింది. ఇది ఫస్ట్ దానికి నువ్వు ఒకటే కనుక్కుంటున్నావు, అన్నమాట చేయగానే నీకు లెఫ్ట్ మోస్ట్ బిట్ వస్తుంది.
రైట్.
తర్వాత ఏమంటున్నారంటే నువ్వు రొటేట్ చేస్తే కానీ నీకు
రొటేషన్
ఆ బిట్ రాదు, సెకండ్ బిట్ రాదు అంటున్నారు.
అవును.
ఆ తర్వాత మళ్ళీ రొటేట్ చేస్తే కానీ థర్డ్ బిట్ రాదు.
థర్డ్ బిట్ విల్ కమ్ ఇన్ టు ద కరెక్ట్, అంతే.
ఈ మూడు యాడ్ చేసుకుంటే కానీ నీకు 3 బిట్లు అకౌంట్ ఫర్ అవ్వవు.
అవును, అంతే.
మనం అక్కడతోటి కథ
అయిపోలేదు. అవును, అది ఒక టర్మ్ అంతే. ఫోరియర్ ట్రాన్స్ఫార్మ్లో ఒక టర్మ్.
మీరు మళ్ళీ ఏం చెప్తున్నారంటే నాయన నువ్వు x2 కూడా నువ్వు
సేమ్ ప్రాసెస్.
నీకు ఇక్కడ 2 టర్మ్స్ వస్తాయి.
అవును, ఎగ్జాక్ట్లీ.
అది ఏమిటి, మీరు ఎప్పుడు ట్రీట్మెంట్ రైట్ నుంచే తీసుకుంటున్నారు.
అవును.
సో ఫైనల్ ఒక డౌట్, మరి ఇప్పుడు అవుట్పుట్ తీసుకున్నాం అనుకోండి, ఇది కూడా మళ్ళీ ఉల్టా వచ్చినట్టే కదా సార్.
అందుకనే స్వాప్ గేట్ చేస్తున్నాం కదా. ఏం చేస్తున్నాం, మిడిల్ వన్ అలానే ఉంచుతున్నాం. మిడిల్ వన్ నో చేంజ్, మిడిల్ వన్ చేంజ్ అవ్వదు. ఇప్పుడు మనకేమైందంటే మన ఆన్సర్కి ఫోరియర్ ట్రాన్స్ఫర్మేషన్ ఆన్సర్కి ఫస్ట్ టర్మ్ లాస్ట్ టర్మ్ ఇంటర్చేంజ్ అయినాయి. మిడిల్ టర్మ్ నో చేంజ్. ఇక్కడ చూడండి, మిడిల్ టర్మ్ యాజ్ ఇట్ ఈస్. This came here and this one came here, I think. That's why what we are doing is we are applying a swap gate for 1 and 3. అన్నిటికీ అవసరం లేదు. మనకి ఏవైతే రివర్స్ చేయాలో అది. మిడిల్ అవసరం లేదు ఇప్పుడు. ఒకవేళ 4 ఉన్నాయి అనుకోండి, నా అప్పుడు ఏం చేస్తారు, అదే మీరు చేసిన తర్వాత చూడండి, మీకు అక్కడ ఆర్డర్ ఏది చేంజ్ చేస్తే వస్తుంది అనేది. ఎస్, సీ దట్. అవును, x1
క్యూబిట్ నేను చేసేసినప్పుడు నాకు ఏమొచ్చింది అంటే అన్ని అకౌంట్ ఫర్ అయిపోయాయి. x1 x2 x3 x4 అన్ని అకౌంట్ ఫర్ చేసాను. అంటే పాయింట్ x1 x2 x3 x4 వచ్చింది.
రైట్.
నెక్స్ట్ దానికి వచ్చేటప్పటికి నాకు ఏమైంది అంటే x2 x1 వచ్చాయి.
పాయింట్
x2
x3
x3 x4 వచ్చేసారు.
yes కరెక్ట్.
సో x3 కి పాయింట్ x3 x4 వచ్చింది.
రైట్, అంతే.
పాయింట్ x4
కానీ మన ఫోరియర్ ట్రాన్స్ఫార్మ్లో ఈ టర్మ్ ఫస్ట్ ఉంటుంది, ఇది లాస్ట్ ఉంటుంది. నెక్స్ట్ ఇది సెకండ్ ఉంటుంది, ఇది థర్డ్ ఉంటుంది.
సార్ ఇది ఎలా స్వాప్ అయింది సార్? x1
ఆర్డర్ సార్. ఫోరియర్ ట్రాన్స్ఫార్మ్ ఏమో స్టార్ట్స్ ఇన్ ఫ్రమ్ 1 decimal. this one.
Ah,
One decimal. I mean after decimal one bit. Next 2 bits, next 3 bits, next 4 bits, next last n bits. Okay. Now here what happened? We are getting n bits first.
correct.
That's why we have to take this first one to last to first.
Because Fourier transform started with the last bit.
Yes. One decimal value. Shall we say, sir, ఇది one decimal value అనొచ్చా దీన్ని?
Oh yeah.
One decimal value. Next 2 decimal values.
Binary fraction ante saripotundi.
Next 2 decimal points. Next 4 like that. ఇప్పుడు మీరు 5 తీసుకున్నారనుకోండి, మిడిల్ చేంజ్ చేయాల్సిన అవసరం ఉండదు.
Okay.
అంతే కదా.
Odd fellow కి చేంజ్ చేయకు.
మిడిల్ వన్ చేంజ్ చేయొద్దు, మిగతా చేంజ్ చేయాలి. ఈవెన్లో అయితేనేమో మిడిల్. ఇప్పుడు 3 తీసుకున్నారు, మిడిల్ వన్ చేంజ్ ఉండదు, ఈ 2 స్వాప్ అవుతాయి. ఇప్పుడు 4 తీసుకున్నారు, 4లో ఫస్ట్ లాస్ట్ స్వాప్ అవుతుంది, సెకండ్ థర్డ్ స్వాప్ అవుతుంది. 5 ఎస్ బెటర్ దట్స్ బెటర్.
5 అయితే చేంజ్ అవ్వాలంటున్నారు.
5 అయితే మిడిల్ ఒక్కటి చేంజ్ అవ్వదు,
అదే
మిడిల్ చేంజ్ స్వాపింగ్ ఫస్ట్ టు లాస్ట్, అగైన్ ఫస్ట్ సెకండ్ లాస్ట్ సెకండ్ లైక్ దట్ సార్. ఫస్ట్ లాస్ట్, ఫస్ట్ సెకండ్ లాస్ట్ సెకండ్, ఫస్ట్ థర్డ్ లాస్ట్ థర్డ్ లైక్ దట్. ఓకే.
సో ఈ స్వాపింగ్ తప్పదా సార్ మనకి ఇన్వర్స్ ఫోరియర్ ట్రాన్స్ఫార్మ్ తీసుకున్నా కానీ
తప్పదు. స్వాపింగ్ చేయాల్సిందే. స్వాపింగ్ చేస్తేనే మనకు ఆ ఫోరియర్ ట్రాన్స్ఫార్మ్ వచ్చేస్తుంది.
మీరు 2005 ఇవన్నీ చదివారు సార్ మీరు? మీకేమో కంప్యూటర్ లేవు, గూగుల్ లేవు, ఏం లేవు.
అప్పుడంతా థియరిటికల్గానే చేసాం కానీ అది కానీ
సాల్వ్ చేయాలి కదా.
నాకు ఆఫ్ చేస్తాను, పాస్ చేస్తాను వీడియో.